So we're going to shift gears now. We've been dealing with quadratic functions, things like y equals x squared or f of x equals x squared, those two variables implying it's something that you can graph on the coordinate plane. And we're going to move into quadratic equations. So a quadratic equation is an equation of the second degree. Okay, beginning of the year, we did linear equations in one variable. Okay, where our goal was, just isolate that x, get x by itself, use those inverse operations. Most of the time, we just got x equals one number. There were those special cases where it was everything. But for the most part, it was just x equals a number. So here, we're going to have a quadratic equations with the second degree. So for example, x squared minus 4 equals 0. So that x squared, since it's an x squared and not just an x, that's what makes this quadratic. The solutions of a quadratic equation are still the value or values that make the equation true. So looking at x squared minus 4 equals 0, we want to say, what can we plug into x to make it a true statement? So hopefully you realize that x could be 2, because 2 squared is 4 and 4 minus 4 is 0. Or x could also be negative 2, because negative 2 times negative 2 is 4, and 4 minus 4 is 0. If you wanted to, in this case, you could be fancy and use that little plus or minus sign, but you could always just list them separately, but it's up to you. So we're trying to find those value or values that make the equation true. We're actually going to have several different strategies of solving quadratic equations, okay? And the one we're going to focus on today is by using graphs and tables. So first, we're going to look at the graphs of the related function. So first of all, to look at a related function, the quadratic equation has to have 0 on one side. And we can see here that since x squared minus 4 equals 0, we do indeed have that 0 on one side. Going forward, if that 0 isn't on one side, mathematically, we can do things to make that become 0. So if it's not 0, it's not the end of the world. We could fix that. But in order to look at a related function, it has to have that 0 there. So we're going to look now at that expression on the other side. So that x squared minus 4, okay, we're going to take that, and now we're going to say f of x equals x squared minus 4, or y equals x squared minus 4. Okay, this is the related function we're going to look at because, like I said, that x squared minus 4 had equaled 0. And so I have included the graph of x squared minus 4, okay, it is over here. And what's cool about this is if you take a look at our graph, we have our vertex down here. Okay, also happens to be the y-intercept, but I want to focus on those x-intercepts. The x-intercepts of this graph are 2 and negative 2, which, if we go back to that equation we solved above, those were the answers. Okay, and this totally makes sense if you think about it. So originally it was x squared minus 4 equals 0. Essentially, where the y is in this related function, we had a 0 there. So it's kind of like we plugged in 0 for y. And hopefully you're thinking, with what we've learned, when 0 is the y, that's the x-intercept. So when you have a graph of that related function, the x-intercepts are the solutions of that original equation. Now, honestly, to me, this is not the best way of solving quadratic equations because graphing quadratics is not the easiest thing to do. It can take a little bit of time. But this is going to be really good if they provide the graph of the related function, or, if you have a graphing calculator, or if you pull up Desmos, you could always use that also. But this probably wouldn't be my first option of solving. But like I said, if the graphs are given to you, it's really good to use that. So solutions to the equation of f of x equals 0 are called zeros of the function. You might also hear them referred to as roots. And just once again, related to that related function, it's going to be the x-intercepts. The x-intercepts of that related function will be the solutions of that original equation. Okay, so you notice in this case, there were 2 different answers because it crossed the x-axis twice. There were 2 x-intercepts. Let's look at 2 other examples here. I'm going to scroll down. So we're looking at x squared minus 4x plus 4 equals 0. So because we have that equals 0, we can take that and write a related function. And I graphed that related function for you already. And here we can see that the x-intercept is only 2. It only hits that x-axis once. There is only one intercept. So for this equation, the only answer is going to be x equals 2. And for the last one, we want x squared plus 4x plus 6 equals 0. We had the equals 0. So that is the related function we're going to graph. F of x equals x squared plus 4x plus 6. And in this graph, it doesn't even hit the x-axis. There are no x-intercepts, okay? Meaning there is no solution to this quadratic equation, okay? So when you have a parabola whose vertex is above the x-axis and it's opening upwards, okay, it's not going to hit the x-axis, so there's no solution. If for some other equation, we had the vertex below the x-axis, but opening downwards, okay, that's also going to not hit that x-axis, and there's going to be no solution. Okay, so as a review, there were 3 cases we just looked at, okay? When that vertex is on the x-axis, okay, that's going to mean that there's only one solution. If the parabola of the related function hits the x-axis twice and there's 2 x-intercepts, there's 2 solutions. And also I should note, you'll probably see real. So this is 1 real solution, 2 real solutions. Up here, there's no real solution. That's going back to those number systems that we did beginning of the year. And so that's talking about the real numbers, because we said that there could also be imaginary numbers, okay, those weird scenarios with like negatives and the square roots and stuff. So this is just saying if there's 1 real solution, 2 real solutions, or no real solution. Okay, let's go to example 2, using tables. Okay, so for our first one, we have x squared minus 7x plus 6 equals 0. How would you use a table to find the solutions of that? So really, at this point, you would have a graphing calculator. Okay, and you'd plug in that related function, y equals x squared minus 7x plus 6. And we would go to the table mode, and it would list our values of x, okay, give values of y, but we're looking for those x-intercepts, meaning where the y is 0. So you can see from this table that x equals 1 and x equals 6 would be the solutions to that equation because their y values are 0. Super easy. Okay, let's look at the last one here. We have 3x squared plus 5x minus 2 equals 0. Okay, we enter in that related function into that graphing calculator. And when we pull up the table in this case, we see one x value that has a y of 0. So we know x equals -2. And you might be tempted to say that that's our only answer, okay, because there were definitely cases that we were looking at before where there was only one answer. But we have to kind of do a little more digging into this one. So I actually put the graph of this one here to reference, okay. Obviously, this example is using a table, so we wouldn't really be looking at the graph at this one. But looking at this graph, we can see that there's 2 answers. There's 2 x-intercepts. So what's happening here is looking at these y values. These y values up here are all positive, and as they continue, it hits 0, and then they become negative. And then these y values are all negative over here, okay? I'm totally hoping you can see my cursor. If not, that's going to be silly. But looking at the bottom part, I guess I'll do this. The bottom part of the parabola, these y values are all negative. Okay, so up here they're positive. Here it was 0. Here they're all negative. And then as we go back up the other side of the parabola, they're still negative over here. It hits 0, and then they become positive again. So whenever the signs change from positive to negative or negative to positive, okay, that means there must be a solution somewhere in the middle there, because at some point, in order to switch signs from positive to negative or negative to positive, it had to hit 0 at some point. So going back to this table, we have that 0 there. Okay, these are all negatives. But from here to here, from that -2 to 6, okay, that changed signs. So we have to realize that at some point there, as it jumped from -2 to 6, it had to hit 0. Okay, so obviously with this table, we're not exactly sure, but there has to be some other answer between 0 and 1. And that's why it says estimate in this case, because it's not going to be an exact answer. So I don't know, maybe I would say 0.6, because it jumps from -2 to 6. So I'm thinking it's probably a little bit on the higher side, closer to 1 there. So this 0.6 is an estimate, but we had to realize in this case that there were still 2 answers, even though that 0 only appeared once in that table. So just a review of that last example too. When using a table, you're going to first look for x values that have a y value of 0. If there's 2 of them there, awesome, that's your 2 answers, because you can't have more than 2 answers to a quadratic equation. But if there appears to be only one solution or none, you must check to see if the signs of the y values change. Okay, did they jump from positive to negative or from negative to positive? If they change signs, it must have hit 0 somewhere in the middle there. Okay, so that's our first way of solving quadratics, is by looking at the graphs of related functions. It could be no solution, 1 real solution, or 2 real solutions. And going forward, I'll give you some more ways of solving these quadratic equations.